All right, so I'm going to talk a little bit about Module 2, Lesson 2 now, and this one is mostly about writing the equation for lines. And so this is a linear equation. We've seen these before. We've graphed these in Module 1. But this is in a specific form. We talked about it a little bit last time. It's y equals mx plus b. When we have that equation that's solved for y, we call this slope-intercept form. And it's really useful to us for graphing. It's why we like it the most, because it's very easy to get a graph when you have this form, because this m value here, we've talked about how that is our abbreviation for slope. And then this b value here is our y-intercept. That's why we call this the y-intercept form for a line. We can read the slope right off of there. We can read the y value for our y-intercept off the b on the end. So for this particular line, this y equals 1/2 x plus 3, we know our slope is 1/2 because that's our x coefficient, and it's just the number. You don't want to include the x on there. Slope for lines is going to be a constant every single time. And then this 3 on the end is our b value, and so 0, 3 is our y-intercept. Okay, and the really nice thing about having exactly this information is it's exactly what you need to graph this line. You don't have to plot points. You don't have to do a lot of work like we've done in some of our previous lessons. We're just going to go to our y-intercept, 0, 3, and then that's going to be a point on our graph, okay? And then our slope, 1/2. Remember, slope is a rise over a run. And so that's going to tell us how to go from our y-intercept, our first point, to a second point. So from that y-intercept, I'm going to go up 1, and then over 2, and that'll take me to a second point up here. Okay, and then once I have 2 points, that's all you need to define a line. We've talked about that when we graphed in the past. When we have 2 points, we just connect them up, and we've got our line that goes with it. So the nice thing about slope-intercept form is it gives us exactly the pieces that we need in order to graph our line. Our y-intercept gives us a place to start. Our slope gives us a rise and a run that we can use to move to our next point. Okay, another big part of this lesson is we're going to give you information, and we'll give it to you in a few different forms, but we're going to take this information, we're going to try to change it into a linear equation that goes with that. And so this is like kind of the best case scenario when you have a problem like this. Like if I tell you that the slope of our line is -5, so m is -5, and it passes through the point 0, 3, okay, this is pretty darn easy to write the equation for if you know what you're doing here, because I gave you everything you need for slope-intercept form. We know we have y equals mx plus b as our general form here. M is our slope, and b is our y value of our y-intercept. So we can just plug right into that if we have this situation. So y equals -5 x plus my b value has got to be 3 because that's the y value for my y-intercept, and I'm done. So if we give you a slope and a y-intercept, we can just plug those right in. We can get the equation that goes with that. Often, though, we will not give you exactly the slope and the y-intercept, the things you need to just plug right in. Like, you don't want to say that the equation of our line here is y equals 5x plus 9. That's not correct, because this 9 value over here is not a y-intercept. The x value is not 0 there. So we have to do a little more work. So this is a little more going on in this problem for sure. And in fact, we're going to need another equation to deal with this. We're going to use this equation called point slope form. It looks like this. Y minus y1 equals m times x minus x1. In order to get our equation for our line, we're just going to plug into this. And the m is our slope, so our m here is 5, and then our x1 and y1 values in this equation are just the x1 and y1 from our point up here. Okay, so we can just plug those in. So it'd be like y minus y1 is 9 for this particular problem, equals m, which is 5, times x minus x1. So x minus, you got to be a little careful with your signs here. We get those two minuses back to back like that. We know that that's going to make that, plus a positive 5 down there. And so we do a little simplifying here. I can distribute this 5 across the parentheses. So 5 times x is 5x, and 5 times positive 5 there is plus 25. And then we like the slope-intercept form. It's generally the form that we want for these things. So my last step here is just going to be to get the y on one side by itself. So we'll move this 9 on over. And I get 5x plus 34. And there's my linear equation. So if I'm given a point and the slope, I've got to use this point-slope form to put all my information together, solve for y. That'll give me my slope-intercept form equation. Another big type of problem in this lesson is going to be if you're given 2 points. And like in the last one, we were given a point and the slope. Here, it's going to be similar, but we're going to add an extra step to the beginning. We don't have a slope for this particular line yet, but we can still get it, right? Remember, in the last lesson, we worked on getting our slope using our slope formula. So that's what we're going to start with here. We're going to take our 2 points. We're going to plug into our slope formula. And remember, the key here is being consistent with your setup. If you're going to start with the 18 on the top, you got to start with the 9 on the bottom since they come from the same point. We'll just work this out. And then we get our slope is 2 here, right? And once we get to this point, it's exactly like the last problem that we just did. We have a couple of points, and we just want to pick one of them to work with. And we have our slope that goes with it. And with those 2 things, we can plug right into our point-slope form for a line. So I would just do like y, well, I'll write the formula again, m times x minus x1. We'll plug in. I'll just use this first point. Again, it doesn't matter. You can pick either point. You'll get the same results. So you can't pick wrong here. I'm just going to choose the first one. So y minus 16 equals m times x minus 8. But you do have to be consistent. You got to pick one of the points and go with it for both of them. And then we'll just solve for y. We'll distribute here. Move that 16 on over. That'll get rid of those. And so y equals 2x will be my equation. So this is a situation where we need to get our slope first. And again, we've done that with our slope formula. Once we get that slope, we just pick one of the points to be our x1 and y1. And then we plug in, and that'll let us solve and get the y by itself on one side. Okay, so hopefully that's a decent introduction to our Module 2, Lesson 2 material. Please let me know if you have any questions.